transformation technique problems. So here the given examples, here the given examples, see here, examples. Consider the circuit shown in figure. Consider the circuit shown in figure. Find the value of resistance R. Here the voltmeter is showing 5 volts. The voltmeter is showing 5 volts. Here figure 19, the circuit consider in example 2. Solution, the voltmeter measures the voltage across one of the circuit sources. The given figure below, the figure 20 shows the circuit after the replacing the voltmeter by the equivalent open circuit and adding a label to show the voltage measured by the voltmeter. So here the figures 21 through 24 illustrate the use of the source transformations and equivalent resistance to simplify the circuit. Here the figure 20, the circuit from the figure 19 after the replace. See here, what is the difference here? Here they are replacing the meter labels only. Meter is replaced by the labels here, plus minus. The red gives the plus and black gives the minus. See, observe this one. Here they written at 5 volts. Here this is the 5 volts plus minus and 4 amps at the left side and 4 amps also right side. The 4 amps is downwards left side and 4 amps towards the upward side. 10 ohms, 5 ohms resistance R. Here the voltage across the 4 amps is 5 volts and it determines the resistance. Figure 20, the circuit from the figure 19 after the replacing the voltmeter by an open circuit, 4 amps 10 ohms, 4 amps 10 ohms. So how these two are the current source in parallel with resistance? How could we convert? So this convert into voltage source. How? This current into resistance which gives the voltage that is in series with the resistance, that is the voltage transformation technique. Here current is 4 amps and the resistance is 10 ohms. 4 into 10, that gives the 40 volts in series with 10 ohms. So this is, see here in the Figure 21 separating the circuit from the 20 into two parts. This is the circuit. Here voltage is 40 volts, that is in series with 10 ohms, and remaining circuit as it is. Here figure 22, the circuit from figure 21, after doing a source transformation, here, so 40 ohms, 10 ohms, 5 ohms. How these two are elements resistors? These two elements resistors are in series. So 10 ohms and 5 ohms. These two are in series. So we could get, these two are in series, we could get 10 ohms and 5 ohms, which gives the 15 ohms, that is in series with the voltage source 40 volts. So figure 23 separating the circuit from figure 22 into two parts. Here 40 volts is in series with 15 ohms and resistance R, and the current source is 4 amps. The current source is represented by arrow, and the voltage source is represented by plus minus. So here figure 24, the circuit from figure 23 after the replacing series with an equivalent resistor. Here they given the nodes. So what are the nodes? 1 and 2 nodes. They given the nodes here 1 and 2 within circle. Now in figure 25, the circuit from figure 24, after numbering the nodes 1 and 2, these are the nodes. Figure 25 shows the simplified circuit after numbering the nodes. Let V1 and V2 denote the node voltages at node 1 and 2 respectively. Then the node voltages are, here see, here V1 is minus 40 volts, V2 is 5 volts there. So V1 is equal to minus 45 and V2 is equal to 5 volts. So by applying KCL at node 2, here the 5 volts is equal to, not 5 volts, this incoming current 5 by R is equal to, here 5 by R is equal to, so minus 40 minus 5 divided by 15 plus 4, that is equal to 1. So which gives the R is equal to 5 ohms. R is equal to 5 ohms. So this is the resistance value of this circuit we calculated by source transformation technique and applying the KCL at nodes. Now go for example 3. Now go for example 3. See, once you read this one, observe this one clean. Consider example 3. Consider the circuit shown in figure 26. Find the value of the voltage measured by the voltmeter. See this circuit, observe this one. The voltage source at the left side is plus minus 16 volts in series with 4 ohms and 12 ohms, 6 ohms, 1 amps. The voltmeter is connected across the 1 amps source. Figure 26, the circuit consider in example 3. Solution. The voltmeter measures the voltage across the current source. So here the color coded probes of the voltmeter indicates the reference direction of the voltage measured by the voltmeter. Figure 27 shows the circuit after the replacing the voltmeter by equivalent open circuit and adding a label to show the voltage measured by the meter. Voltage measured by the meter. Here, figure 28 through 35 illustrate the use of source transformations and equivalent resistance to simplify the circuit. See here, this circuit and this circuit. Here the meter is removed and labels the minus plus and Vm. Here the circuit from figure 27, the circuit from figure 26 after the replacing the voltmeter by an open circuit. Here the minus indicates that black color code and plus indicates that red color code. See here, this is the positive, red is positive and black is negative. "16 volts, 4 ohms." So here the 16 volts is the voltage source, that is in series with 4 ohms. Here 16 volts and 4 ohms. These are in series. So here remaining circuit is as it is, that is 12 ohms, 6 ohms, 1 amps, and the meter indicates. Figure 28 separating the circuit from figure 27 into two parts. Here the voltage source and resistor in series, so we get voltage by current, voltage by resistance, we get current. Voltage is 16 volts and the resistance is 4 ohms. That is 16 by 4, which gives the 4 amps. That is in parallel with 4 ohms. Here see, is 4 amps in parallel with 4 ohms. 4 amps in parallel with 4 ohms. Here figure 28 separating the circuit from figure 27 into two parts, that is 4 amps and 4 ohms. So here figure 29, the circuit from the figure 28, after doing a source transformation, figure 29, the circuit from figure 28, after doing a source transformation, see here, in general, here the 4 ohms and 12 ohms, 4 ohms and 12 ohms, those are in parallel. So resultant is 4 into 12 by 4 plus 12. That is how much? 4 into 12, 48 by 16, that is 3. So that is 3 ohms. Figure 30 separating the circuit from figure 29 into two parts. Here, see, observe this one, 3, the current is 4 amps, that is as it is, and the resistance is 3 ohms, equivalent is, that is 3 ohms, and before that 6 ohms and 1 amps as it is. Now here the 4 amps and 3 ohms, the current source is in parallel with a resistor. So here, which gives the voltage source. Figure 31, the circuit from figure 32, after replacing parallel resistors with an equivalent resistor, see here 4 amps and 3 ohms, that is 4 into 3, 4 into 3, that is 12 volts, that is in series with resistance, that resistance is 3 ohms, and the 6 ohms 1 amp, and the meter Vm is as it is. Here figure 32 separating the circuit from figure 31 into two parts. Here the current source convert into voltage source, that gives the So 4 amps and 3 ohms, those are in. So convert into voltage source. Here 4 into 3 and in series with 3. 4 into 3 is 12 volts. That is 12 volts in series with 3 ohms and 6 ohms on amps as it is. Before that, what is the value? Here figure 33, the circuit from figure 32, after doing a source transformation, here, say observe this one, 3 ohms and 6 ohms, these two are in series. So how these two series 3 ohms and 6 ohms, how much resultant resistance? 3 plus 6, that is 9, is in series with 12 volts. The circuit from figure 32, after doing a source transformation, here 12 volts 3 and 6 are series, that separating the circuit from figure 33 into two parts. So 12 volts 9 ohms and 1 amps. This 12 and 9 ohms. See here, circuit from figure 34, after replacing a series resistor with an equivalent resistor, see here figure 36 reduced to circuit. Figure 36 shows the simplified circuit after labeling the current and voltage of the 9 ohm resistor. Applying KVL to the loop circuit gives 9 minus Vm minus 12 equal to 0. That is Vm is equal to minus 3 volts. This is the voltage across the meter. Now go for another example. So consider the circuit shown in figure 37. Find the value of the voltage measured by the voltmeter, as it is somewhat different. The circuit considered in example 4, voltmeter is given the connected across the 4 ohms, 6 amps is the current source, and the 6 volts is the voltage source. Here the voltmeter measures the voltage across 4 ohms resistor. The color coded probes of the voltmeter indicate the reference direction of the voltage measured by the voltmeter. So here figure shows that the circuit after replacing the voltmeter by the equivalent open circuit and adding a labels to shows the voltage measured by the meter. Figure 40 and 47 illustrates the use of source transformation and equivalent resistance to simplify the circuit. Here 6 amps, 16, 6 volts, 20 ohms, 4 ohms. Here labeling plus minus Vm. Figure 39. Here 6 amps and 16 ohms. These are in. So here current source get convert into voltage source. So 6 into 16 is in series with 16 ohms. 16 into 6 is 96 volts. That is a voltage source in series with 16 ohms. Now 6 volts and 4 ohms and 20 ohms. So here the circuit from figure 40 after doing a source transformation, so 96 and 6 volts. Here these are quite opposite polarity. So this opposing polarity. So 96 minus 6, which gives the 90 volts, and all resistors are in, what is that, in, so series. Now here 96 and 6 volts, which gives the 90 volts, and the remaining resistance are same here. Figure 42, the circuit from figure 41, after changing the order of series elements, so 96 6, 4 ohms, 20 ohms and 16 ohms. Here separating the circuit from figure 42 into two parts, so resultant is 90 volts, 4 ohms, 20 ohms, 16 ohms. Figure 44, the circuit from figure 43, after replacing series voltage source with an equivalent of voltage source. Here, see, observe this one. Here they are asking voltage across the 4 volts, but here 16 ohms and 20 ohms, these are in series. Now here, so 90 volts, 16 ohms, 20 volts, that is 36 ohms. Here the 90 volts, the figure 45, separating the circuit from figure 44 into two parts, 90 volts, 4 ohms, 36 ohms. The across the 4 ohms is Vm. The circuit from figure 45, after replacing series resistors with an equivalent resistor, so 90 volts minus plus the 4 ohms and 36 plus V minus. Here the reduced circuit figure, the 47 shows that simplified circuit, the voltage division gives, the voltage across the meter is, so here 4 by 36 plus 4 into 90, which gives the 9 volts. Which gives the 9 volts. This is the, here this is the 9 volts. Here the 9 volts. This is the technique of source transformation technique in the given problem.